Hello, thank you so much for checking out my science fair project. I developed a feedback control loop to maintain the stability of an inverted pendulum. Before I get into more details, let me show you my robot in action along with a brief overview of my work. I've always been fascinated by the giant robots from Japanese science fiction comics. I like to see us be able to walk around inside of these large robots that tower 2 or 3 stories tall. Someday, I hope to make a project like this a reality, but as a crucial first step, I decided to tackle the problem of balance first. When we walk, we are effectively solving the inverted pendulum problem naturally. With every step we take, we are catching ourselves from falling by using a gyroscope in our ears. But how could you implement this into a robot? I decided to build this two-wheeled robot that can balance and move. What you're watching right now is a demonstration of my working final product. When it begins to fall, the gyroscope sensor tells the wheels to move accordingly to catch itself, and does this 200 times a second. To accomplish this, I used a PIPD software controller. I'm really happy with how this robot turned out. In conclusion, I hope to someday build a robot with arms and legs that walks like a human, but this was a big first step on that journey. I discovered that I didn't need to fully simulate and model what was happening with the mini Segway if I used a gyro and some software. The gyro measures where we are and can be used to detect if we are falling. It's like a thermometer in that sense, because it measures reality. What I needed to build in software was a thermostat. I used a technique called PID control, which calculates and minimizes 3 types of error: proportional, integral, and derivative. I ended up with a PI controller that fed into a PD controller. The PI controller took my desired speed and produced the desired angle for the robot to tilt forward. The PD controller then took that desired angle and modified it with the acceleration of the motors. Thank you for listening.